Okay, I think. Yeah. Okay, sorry. Well, it seems to take a little longer than expected, but it's all done now. So it's a little dark down there, but Michael and Jonathan, are you down there?
Yeah, yes.
Great. Okay. So I had a little email exchange yesterday, and I was originally going to teach this class from down on the coast, but iTech needed to install some software in this lab up here. Well, I needed iTech to install some software. So on that same note, for those of the students that are up here, they told me at 2 o'clock they're gonna remotely install the software. It's SPSS. It's for my other class, which about half of you are in that class. So at 2 o'clock, your computer might. So I don't know how it's going to work, but at 2 o'clock, the computers you're sitting at might not work because they'll be installing this other software. So in that case, you just have to follow along with what I'm talking about, and hopefully it won't take that long to actually install, and maybe by the time that the lecture is over, it'll be ready to go. So what I plan to do is I still want to go down to the coast. So I'm probably going to do that on Thursday. Thursday, so like in 2 days. And if that's okay with you guys on the coast, yeah, go ahead. I thought it was on Wednesday. It's on Thursday? Oh, I'd planned to be here tomorrow. I really did think it was Wednesday. Okay, so I guess it'll be Tuesday that I'll come down to the coast. Is that okay, Jonathan and?
Yeah, that's fine.
Okay. I'm really glad that I didn't just announce this down. I could have just replied to them. Okay, well, I would have figured it out because I would have come here tomorrow at 10. It's at 10:30, right? Yeah. Yeah. So for some reason I was thinking it was tomorrow at 10:30. So it's on Thursday at 10:30, and that's fine because this class doesn't have until 1. So, all right, no problem at all. Everything's good. Next Tuesday I'll be down on the coast. This Thursday, evidently, sorry I messed up. I did know that it was happening. I just got the wrong day. Okay, so thank you very much. All right, so what we want to talk about, really, we have 3 weeks of content left in this course, and what I want to talk about for those 3 weeks, you could summarize it or categorize it in a few different ways, but I want to talk about it in terms of doing GIS operations on the web. Okay, we up to this point we've been displaying geographic data, and we've done some things that are kind of like GIS operations, where we like make a circle grow or shrink. But we want to take that a little bit further. Okay. When I say a GIS operation, or when I say GIS analysis, what does that mean to you? What is doing GIS analysis? I'm pretty sure I did, but thanks for, yeah, I did it before I even turned the camera on, so it's gonna roll for a few seconds. That is, don't feel bad for reminding me to do that, because that's a very important thing to get that set up. So yes, it is set up. So in terms of GIS operation or GIS analysis, what does that mean to you? What type of operations would you perform doing GIS analysis, or what would that mean? Doing a clip, like, what does that mean? Taking one, right? Taking one feature and taking off part of it. Why would you do something like that? Mm-hmm. To show areas where they overlap. So, like, let's say you had a you had a fire station, and you wanted to show all the areas that were within, 2 miles of the fire station, and all the areas that were also within 5 miles of a school or something. So I don't know if that's the best example, but those would be two things that you could show, and then you could show the intersection is another word for that. In fact, yeah, we have a lot of different GIS operations, but most of them can be boiled down into a few operations. I use the word intersection. Intersection is a very commonly used term to mean the overlap between two features, right? Intersection. And so in ArcGIS, the concept of intersection is implemented in a few different tools. One of them is CLIP, and one of them is intersect. Really quickly, how are those different? The tool that's called intersect in ArcGIS and the tool that's called CLIP, how are they different? What's going on different between CLIP and intersect? Anybody think about those?
Put off the area that's in the left.
Right. So let's say I have two different. Oh, here. This is actually kind of good stuff. Let's see. Do I have? Yeah. Okay. So if I have a polygon right here. Oh yeah, that's drawing it. If I have a polygon and I were to draw another polygon, okay, and I took this the square shaped polygon, and that was my initial polygon, and I used this polygon here, the circle polygon, to clip it. What would the result be? The intersecting area would disappear. That's in ArcGIS. This could be different in different GIS software packages, but in ArcGIS, the tool that I think you're thinking of is called erase, where the intersecting area would disappear. So clip. I don't know if anybody said this yet, but if I used the circle polygon, it's kind of like a cookie cutter, and it would clip, and this would be the area that was left. This area right here. Okay, if I did a clip. By the way, I appreciate all the any feedback, any answers to questions, even if it wasn't correct in this case. So this overlapping area right here would be what would the result would be in a clip. Okay, what would the result be in an intersect? That's the point I'm trying to get across here.
Both polygons would still be there, but the intersecting area would be a different color, the two.
That's really close. So there is actually only one polygon on an intersect. However, it would be the overlapping area. And so the overlapping area would be this area right here. So the clip and the intersect, in terms of the output, what it looked like spatially would look exactly the same. Okay, and we're not going to demonstrate it. You're just going to take my word for it. But the spatial extent of both the clip and intersect for both of these two layers would look the same. The difference would be where. I think that you were getting pretty close. I don't know if it was Michael or Jonathan that commented, but you were going down the right path with your answer. It wouldn't be two polygons, but it would have the attributes of both the polygons. And maybe that's what you meant. You see what I'm saying? And the intersect would carry forward the attributes of both of the polygons, whereas the clip would not. Okay. So that's the difference between a clip and an intersect. So technically, like in outside of ArcGIS, like in literature, or just when we're talking about GIS operations in general, an intersect does two fundamental GIS operations. It does what we call a GIS intersect, and then after it does the GIS intersect, it does a spatial join. A spatial join. It takes the features that are the same spatially, and it assigns the attributes from the joining feature to the target feature. Okay, so the intersect tool in ArcGIS does that. The clip tool just does a spatial. It just does a spatial intersect, and then it doesn't do any spatial joins, except for it carries through the attributes of the target feature, not the clip feature. So if we determine this was the target feature, it would have the attributes of that one. If we determine this was the target feature, it would have the attributes of that one, not both. So that's the difference there. All right, that sort of information will come up here in a second. But yes, these types of things are spatial operations, GIS operations. Now, there are some operations where they're not technically GIS operations, but they're kind of in the information systems realm that most GIS software packages can do. Maybe just a little bit of a guessing game, but what might we be talking about? They're not spatial operations, but GIS software packages do them a lot. Summarizing data, for example. So GIS operations can calculate, can create a new field in an attribute table, and can calculate summaries from a field. Find the mean of this field, find the high, the maximum value, the minimum value, those sorts of things, and even summarizing by another attribute. In other words, find the mean for household income for all these counties, but do it by state. So tell me the mean in California, the mean in Mississippi. Those are the sorts of things. Those, if you think about it, even if I'm doing it by state, it's not spatial. It's pulling all that information in from the attribute table. Okay, it's not pulling it in from the spatial information. But it is, it's something GIS software packages can do. They can manipulate the attribute table side of the equation. So we got spatial operations and some attribute operations that GIS software packages are good at doing, and we can call all those GIS operations, even though not all of them are spatial in nature. Okay. Now, if we ask for it to calculate for something like area, that would be a spatial operation. Ask to calculate the length. All right, and so all GIS software packages are, well, not all they are, but what makes a GIS software package is that it has these abilities to perform some or a lot of these spatial operations on spatial data, and often that it can do attribute type operations on attribute data. All right. So far, we haven't really done any of that, or very little of that, with our data. Okay. But you think that it would be powerful to have that sort of capability in a GIS in a web mapping application. Yeah, probably would. So we're going to talk about 3 different ways that we can implement and utilize GIS operations in a web application. Okay. And we're going to go over these over the next 3 weeks. The first one that we're going to cover is doing GIS operations right in the browser. The reason why I'm talking about this first is because we just got done talking about vector data in the browser. So doing a GIS operation right in the browser requires that you have the GIS data in your browser, and that is stored in vector format, points, lines, and polygons. So it is possible to perform a spatial intersection right in the browser, or a spatial union, or finding other examples. Might be finding the bounding box of a particular feature. Okay, it's even possible to do things like this, where we're doing a spatial join in a browser. Okay? Now, if you think about writing all the code for doing that yourself would be difficult, if not impossible at this point. I wouldn't want to tackle it. But these are basically GIS software packages that have been written in JavaScript for the web. That's what we'll talk about first, and we'll come right back around, and that's what we're going to actually talk about and demonstrate today, is GIS operations for the web that are browser based. Okay, and these again. Well, we'll talk about that in a second. So the second one that we'll talk about, that we'll probably talk about next week, is, and this is a little bit different order than the syllabus, is publishing what we call a geoprocessing service. Now, when you publish a geoprocessing service, what happens is that you're still looking at a map service, and you respond to some user interaction, and your geoprocessing operation, or your GIS operation, actually takes place on the server. And just like a map service, there's a little program running that's waiting for you to submit results. For example, you might submit a point location. Here's a point location to the server and say, find me all of the homes within 200 meters of this area. So you submit that request to the server. The server then executes and finds all of the homes within 200 meters of that area. It performs that geospatial operation. And then that information gets returned back to the back to the client. And it could be that it gets returned as a map service. So in other words, it's just a PNG that as you move around, it draws a new PNG. It could be returned as GeoJSON. So it could be returned as vectors. And so then the browser would then be responsible for drawing that layer on the client. Or it can be returned in a few other formats. Those are the most common ones, though. It's returned as vector data. It's returned as a map service. So that's what we'll cover when we meet next week. And so that'll be a good one to cover while I'm down on the coast, just to make sure that that it works as a from that site, okay? Because we're going to be accessing the server backend today. We're not going to be accessing the server backend for another week, like we have in the past. Okay, maybe I should write these. Let's delete this. Okay, so we're talking about GIS operations in web apps. We can do one, browser-based vector GIS operations. Two, ArcGIS calls it geoprocessing, and that's server-based GIS operations. And then finally, number three is really just a modification of that second one. Okay, number three is geodatabase spatial operations. All right, and in this method, where we interact directly with a geodatabase. Okay, we interact directly with a geodatabase like PostGIS or MySQL server, MySQL Spatial. We interact directly with them, and these databases have methods to do GIS operations like this. In other words, we can say, okay, I want to set up a query where I do an intersection and a spatial join, and I want to return the results. So really, the only difference between 2 and 3 is that in 2, the request goes to our GIS server that's running ArcGIS server or some other GIS server. It's running GIS code. Or with number 3, the request goes to a database server where our data is actually stored. Okay? But they're very similar in that the request goes out to the server. The main difference is in number 3, there is not a map server there to draw the results. So in number 3, the results almost always come back in some sort of vector format. In other words, the points and lines and polygons come back usually in a GeoJSON format, and those are symbolized. There is an exception, or there's not an exception. There's a combination between 2 and 3 that we might get to. We might not have time, but there's a combination between 2 and 3 where our GIS server is the only one that I know of that allows for this at the time. You send your request to ArcGIS server, and ArcGIS server then handles dispatching the request to the geodatabase. Geodatabase returns its features. GIS server draws them for you and hands them back as a map service. Okay. I use that. I actually use that in some of the web apps that I have created. So that's a blending of 2 and 3. Okay, so that's what we're going to spend the next 3 weeks talking about, is doing GIS operations. And these next 3 weeks we're actually going to be doing some GIS operations, and so it might seem a little. We're adding another layer of complexity. So we've got the web stuff that might seem unfamiliar, and now we're adding the GIS operations on top of that, which if you haven't taken a GIS course in a little while, you might need to dust off your, I don't know, the GIS knowledge part of your brain to understand what's going on there. But we'll try to work through these operations slowly, and I believe that the way that we're doing them, we're building on in terms of complexity. So it should be pretty good. So let's start with this browser-based vector GIS operations. That's what we're going to talk about today. And to do this, we're going to utilize a GIS software package. And it doesn't even really call itself a GIS software package, but that's exactly what it is. That's called TURF, or sometimes called TURF.js. So this is an open source GIS software package that's designed to run in JavaScript. And so it has a set of commands that we can utilize that run GIS operations. And you'll see that it's not as feature rich as ArcGIS, and it's not intended to be. There's still plenty of stuff that you would need to do on the server. The advantage to using a package like turf.js, and it's not the only one out there, but I believe it's one of the more complete ones out there. The advantage to using something like this over the server is that although it has less features, it doesn't have quite as many spatial operations, or even half as many spatial operations. It's faster. It's faster because you don't have to send a request out, wait for a process to run, and receive a result back. Okay. Now, just like when we talked about vector in the browser before, there's a point where it becomes slower, and then there's a point where it becomes frustratingly too slow. So this is really good for hundreds of features. It's tolerable for thousands of features. It doesn't work for tens of thousands of features. If you need to do tens of thousands of features, one of the things you might consider is this even something that I want to do on the web? Okay, the web is a place for targeted GIS operations, not necessarily a place to be doing tens of thousands of GIS operations. So you might want to consider that. Two, if you decide, yes, I still want to do it on the web, it isn't appropriate to use a technique like this, where you're doing the spatial operations in the browser. It's much better to do the spatial operations on the server at that point. The other thing that you need to consider is that most of the time, the spatial operations that you do using something like this, they don't do a lot of projection and coordinate system handling, and this one is one of those. Okay, all your data is assumed to be in WGS84 latitude longitude, not Web Mercator, WGS84 latitude and longitude. It'll work if that's not the case, but it won't calculate areas quite right. But it'll still do the GIS operations. But it's best if your data is in latitude longitude. Luckily, most data that's shared on the internet is in that projection. So, all right. So here's the opening page here, and it shows how you. This is an example of one of the GIS operations that it'll do. By the way, remember how leaflet was L dot whatever, and then it had a bunch of operations you could do with L. And jQuery is $$ dot whatever. Okay, well, turf is turf dot, and then whatever spatial operation you want to perform, whatever function you want to perform. So here, turf.tin, tin is the spatial operation. You feed it a number of points, and it creates a tin out of those points, okay? That's probably one of the, well, I shouldn't say that. I was gonna say, that's probably something that's not all that useful. There's other tools in here that I think are more useful, but for a particular operation, that might be very useful. But tell me what a tin is. Triangulated irregular network. Yeah, I didn't hear whether you said everything, but yeah, it's a triangulated irregular network. So it can create a tin, and it's created a tin here with it looks to be 7 points. Let's say you had 10,000 points. You don't want to create a tin in the browser; it would take too long. But if you have 100 or so points, hundreds of points, maybe even 1,000 points, creating a tin in the browser isn't a bad idea, and that's what it's done here. A tin, it creates a surface on the browser, and I'm sure in the API it gives us clues as to how to symbolize it more appropriately. But we're really not going to look at tin today, unless somebody really wants to. All right, so this is the CDN right here. The CDN, remember we covered what that is. In other words, this is a location where the code is hosted for you, and you don't have to download the code onto your file. I'm going to use this GeoJSON example that we've created up to this point, and I'm going to modify that GeoJSON example. And so I'm going to copy this line right here and utilize the CDN so that I don't have to download a copy of turf. So again, turf is a library of Control X of JavaScript for doing GIS operations. So that's the line that I need right there in order to utilize turf. Now, anywhere in my JavaScript code, I can say turf.tin or turf.intersect or turf.union. Those parameters now work. Okay. So that's all I needed. Before I go any further, I'm going to save this as, so I'm going to upload this later. I'm going to save this as a GeoJSON. I'll just call this turf, GeoJSON turf.html, just so that we'll have that later. Okay. All right. Now, what I'm going to click on here is the API doc. By the way, what happens if I said learn? Huh. Those are just some examples. Intro to turf. Probably be good things to read about. So turf is a library for spatial analysis. So that's what I've been saying so far. Huh? Okay. So you can go through and read that if you want. But here's some examples. Turf can calculate buffers. Turf can calculate areas. Those are some of the things that we want to see. If I go to that other page, the API docs, I can see a list of all the functions that are associated with turf. See all the functions that are associated with turf. I've got aggregation, where I can get averages. I can get mins and maxes. I've got measurements that I can take. I can find the midpoint between two features. Scratched my glasses earlier. Nothing that's helping. It's hard to see out of them. You can calculate the centroids. These are all things that you could do in a GIS operation. You calculate the extent. I wonder how envelope and extent are different. Envelope takes any number of features and returns a rectangular polygon that encompasses all vertices. Okay, so let's see how that, I'm curious to see how this is different than extent. Takes a set of features, calculates the extent of all input features, and returns a bounding box. To me, that sounds really similar. I'd have to read to find out more about that one. But those, that might be interesting to someone. Let's say you had the user click different places, and you're interested to find out what's the bounding rectangle of all the locations that they clicked. Well, you could click on, I mean, you could have it run bounding box polygon, and it would create a polygon bounding box of those locations. Here's one that, let's see, where is it? No, maybe it isn't. Yep, convex is what I mean. Sometimes it's convex. Sometimes it's useful to find the bounding area from a bunch of clicks, but you just want to find out, not instead of the box, you want to find out the polygon that creates or that touches all the polygon points. That's called a convex hole. Convex hole is a way to do that. So we've got a convex hole here. Now, if you put another point right here, that point would be inside the polygon. Okay. The convex hole only creates convex angles, and so it won't create a point right there. Now, if you create a point right there and you use concave, it would go into it. That's the difference between convex and concave. But these are all spatial operations. Okay, we don't need to demonstrate every single one. What you need to do is think about, hey, what is my website? What do I want my website to do, and find the operation that does that. Okay, so there's quite a list here. Although you could scroll through it in what is that? A second that it takes me to scroll through all of them. But there are a lot of spatial operations that it could do. Now there's some non-spatial operations. Classification, non-spatial. Okay. All of these are pretty much non-spatial as well. So let's demonstrate a few of these. I'm going to go back to my website. I'm going to see what it does right now, first of all. So this is GeoJSON_turf. Running slow. All right, so this is what it does so far. I'm going to delete these. I'm going to leave just the earthquakes for now. So I got these earthquakes, right? I'm going to get rid of the state boundary, the little polygon that I've created, and I'm going to get rid of these two layers. So I think I put those. Actually, I'm going to do a few things. Okay, so I'm going to get rid of the oyster sites, the town points, bam, keep the earthquakes, and I'm going to, where's the, okay, here's Wyoming. I think if I hit save now, refresh this, there's Wyoming, right? Before I get rid of Wyoming, I'm going to change one thing. So one of the things I did before class was I went online and I just found a bunch of, I just found a GeoJSON. I just actually Googled to prove what I did. I go back to here. I Googled GeoJSON for all the states. Easy. First one that pops up is this website. There are 3 different versions. I clicked on the most coarse. Okay. Sorry, and I clicked on the polygons. Meaning the least detail, I click on the polygons. So I've got GeoJSON for all of the United States. Now instead of having GeoJSON for just Wyoming, I've got GeoJSON for all the states. It looks like it's in latitude and longitude, that's great. I'm gonna hit Control A, and I'm gonna copy this whole thing. Why is there audio? I'm going to copy that whole thing, and I'm going to put, I'm going to create a new file. Actually, instead of creating a new file, I'll open my data.js. Oh, these are just like, my little brother is texting me. All right. I just turned the sound off. Okay, so we've got data, and I'm going to take my Wyoming data that I created before and delete it, and then say Control V and just paste all of the states in there. So now I have the GeoJSON for every state. And I'm going to call this, I'm going to say File, Save As, I'm going to call this state data instead of data. State data. And then I'll rename this state data. I don't need to rename it state data, but I want to keep it separate so that the example still exists. So this is state data. I go back to my GeoJSON turf data, and if I go up to the top here, and instead of getting data.json, which has just Wyoming and the other polygon, I say state data. Now, what will happen when I refresh my page is that I'll get a polygon for every state. Data is not defined. Oh, one more place I have to change. I have to change it right here to state data because I call it state data, not data. If I kept it called data, it would have worked fine. Okay, so now I have every state in there, and I have my earthquakes layer. Okay. When I click on this, it says undefined, pop undefined. Why does it say that? By the way, why when I click on the states, does it say that? Where in the code do I set up the pop-up? There should be a bind pop-up statement in the code somewhere, right? If I go down here, there's a bind pop-up, and it says feature.properties.name. Let's go to my GeoJSON for each state. Under properties, do you see a name? Well, I do see a name, but what's the difference between that name and this name in the code? Right. So you think if I capitalize this, it should work, right? And in fact, it will work. So here's Montana, but the population is undefined. I don't even know if there's an attribute population. There's not. There's GeoID, there's state, there's census area, that's it. So let's just get rid of that so that it doesn't say undefined. Okay, Control S. So now I've got this, refresh it. Now when I click on a state, it'll tell me a state. When I click on a polygon feature, a point feature, the earthquakes, it still tells me that earthquake existed. It's telling me, I forgot the name of the feature. I think it's called place. That's what we had show up. All right, the first thing that I'm going to do is use a non-spatial operation that Turf has called under classification, there's three things. There's Jenks, there's nearest, there's quantile, and there's reclass. Okay? So we set up kind of an arbitrary scheme down here already, right? We said, okay, if it's less than 4.5, then we're going to say that if it's greater than 4.5, we're going to say it's large. If it's greater than 3, it's going to be medium. Otherwise, it's going to be small. Okay. How about we change it so that if the earthquake is in the upper quantile, it's going to be large. If it's in the middle quantile, it's going to be medium. And if it's in the smallest quantile, it'll be small. What's a quantile anyway, by the way? It's a classification scheme, but how does it, what's the definition of a quantile? Or the quantile classification scheme, how does it work? What's that? So yeah, I do it for an attribute, and on that attribute, what happens? There's another word for quantile. It's called equal. What is the word for it? Anyway, quantile means that there's a roughly, if it can do it. In other words, if you have 12 observations and you say you want 4 quantiles, there's 3 observations in every class. So it has an equal number of values in each one. Okay, that's the definition of a quantile. Means that if you do 2 quantiles, what you're doing is you're saying everything above the median is going to be in one class and everything below the median is going to be in another class. Okay, if there are 4 quantiles and you have 100 observations, there'll be 25 in each one. Does that make sense? So yeah, so there's equal area. That's not equal area. It's an equal number of observations in each class. And so you could do that, right? But think about all the JavaScript code you have to write. First of all, you have to write a loop. We haven't covered loops really well. I mean, we could do loops. We have covered them a little bit, but you have to write a loop because you have to loop through all of the values, and then you have to sort them out, and you have to find out where the breaks were to create that. That would be a pain. Okay. Well, turf.quantile will take as an input a feature collection, and it's going to take a field, the field that you want to divide up into it, and then it returns an array of percentiles on which to calculate the quantile values. Okay. Okay, so it's percentile. Sorry, it's percentile. You calculate an array. Yeah. So what we're saying here is we want the break at 25, the break at 50, the break at 75, and the break at 99. And so what we're doing here is putting roughly a quarter of the observations in each class, what that's doing. Okay. So let's copy this line of code, and we're going to do the same thing for our data. So I'm going to do this up for the Quakes data. So when we get the Quakes data back, which is right here, underneath that, we're going to get, well, I want to get some breaks. The breaks are going to be from the Quakes, rhymes. Okay. What's the name of the field? Well, it's mag. We could go look that up, but I remember it. The magnitude field is called mag. And what we want to do is we want to find the lower third, the middle third, and the top value. I guess we don't really need to know the top value, right? So maybe we don't get that. So let's see, we roughly have 33 and 67 would give us the 33rd percentile, the 67th percentile, really it would be 66 point whatever. So we're saying, okay, what are the values, what value represents the cutoff for the 33rd percentile? What value represents the cutoff for the 67th percentile? Make sense? That's what we're asking for here. And so at this point, I'm not going to actually do anything to the data, but I want to show you when I log breaks, it's going to tell me those values. So when I refresh this page, you'll see that I get this is the log of the earthquake features coming back, and then these are the breaks, 2.9 and 4.2. So anything that's less than 2.9, we want to be a small earthquake because it's in the lower third. Anything between 2.9 and 4.2, we want to be a medium-sized earthquake because it's in the middle. And anything that's greater than 4.2, I didn't get because the way we wrote the code, I didn't care what the upper bound was. So anything that's greater than 4.2 is going to be a big earthquake, all the way up to the biggest earthquake that there is. Now, if I actually wanted to know what the biggest earthquake is, maybe I wanted to put it somewhere on the screen and say, the biggest earthquake is this one. I might want to do that. Well, then I would just change this line so that it would also give me, I don't know, 100. I don't know if 100 is going to work or not. Let's see. Yep, 100 works. So the biggest earthquake, remember this is the earthquakes within the last week. The biggest earthquake in the last week is a 5.9. Okay, that's what that's I'm telling you. But I don't really need to know that number for creating the way we coded it for creating it. So we call this breaks. And in order to actually implement this in our code, we would come down here and instead of saying 4.5 now, we're going to say breaks, and it's going to be 1. Okay? And this one is going to be breaks 0. Okay? You might be wondering why those numbers. Oh, this here, right here, is an array, and breaks 0 is this number, and breaks 1 is this number, and breaks 2 is this number. We're not using that number because in our code we're saying, Okay, if it's greater than 1, in other words, if it's greater than the middle number, it's a big earthquake. Give it the big symbol. If it's greater than 0, which is this number, make it the medium symbol, and everything else, just make it the small symbol. Let's reload this, and we might not see much change because those numbers are actually really close to our numbers. Okay, I don't know. I think there are a few more smaller earthquakes, but it's hard to tell. I can't remember, but our numbers were already 4.7 and 3. Those were the numbers we chose. So they were really close to the numbers that it chose for us. Right, there it is on the worldwide scale. Okay. So we used the quantile distribution. We could change this. Like, we don't have to choose percentiles that would create equal numbers in each group. Let's say we only wanted to consider the very large earthquakes to be the ones that were in the 90th percentile. Okay, we could do that, and then we refresh it, and we get that won't affect this map at all. But worldwide, you can see it's created less large earthquakes. And you can see that the new cutoff is 4.9 rather than 4.2. I'm going to leave that at 67. All right, so that's quantile breaks. We go back to turf. We could also do where are the that's quantile breaks. We could also do nearest, which just tells us what feature that's different. It's not a true classification scheme. What about Jenks? What is Jenks? What's another word we use for that? What's actually the most common implemented algorithm for natural breaks is what we usually call that. So Jenks is the most commonly implemented natural breaks system. So we could use natural breaks instead of using quantiles. What if we wanted to do equal intervals? There's no tool for equal intervals. Well, equal intervals is really easy. All we need to know is the minimum value and the maximum value, and then you just divide it up. So it's such an easy thing to calculate to haven't included that as one of the options. Okay. So like I can figure out the min and the max would be 0 and 100, and then I could just take whatever those values were, the highest value and the lowest value, divide those values by 5, by 4, depending on how many classes I want, and then I would have the number I wanted. I'm not gonna do that. All right. So that is a non-spatial operation, but it's still kind of cool. Whoa, that's pretty cool. What just happened? These are the earthquakes in the last week. Remember, there weren't any red earthquakes just a second ago, the last time I refreshed. Now there's a red earthquake off the coast of San Francisco. It's interesting. Yep. 103 kilometers west of Ferndale, California. So that earthquake just happened as we were talking. I don't know what its magnitude is. Let's see if we can get that. That's kind of the largest one's large. I don't know if time was the right attribute. Time is not the right attribute. Let's see how big it was though. Oh. .33. So it's not a huge earthquake, but it's interesting. Now, one of the things that I noticed is that there's actually this error that comes up when I just write .mag. I have to write plus, quote, quote. This is just a quirk of this particular programming language. There's a couple, properties.mag is a number. And so as a number, it won't let me put it in a window. It has to be text. But if I add it to an empty string, quote, quote, then it goes in there. Just so like if you're ever having a problem like that as you're working through an assignment or working on your final project, let me know. Sometimes it's a weird, quirky solution, and that's putting that plus quote quote allowed me to turn it into a string. There are other ways to turn it into a string, but I find that's a pretty easy solution. Let me see what the I'm interested really quick. Yeah, time. All right, so the time that is being reported by USGS here is in milliseconds since the epoch. And I'm not exactly sure what that means, but it's some arbitrary point in time, or maybe it's in seconds. Let's see. That's actually not the number. So it looks like it is in milliseconds. Yeah, so it's in milliseconds since the epoch. And so it does say that occurred on Monday. I didn't think that was there before. But anyway, it occurred fairly recently, that earthquake right there. And let's just change it back to place now, so we can find out what time that occurred by looking up that particular thing. 103 west of Ferndale. Okay, so that was essentially aspatial. Let's do one more thing that's not spatial. Let's calculate maybe this isn't a valid thing, but let's calculate the average size of an earthquake by state. Okay, I want to show you that that's a pretty easy operation inside of what do you call it? Inside of a turf or inside of a GIS system. So how would we do that? We'll go back up to turf for a second, and you can see that there's one called average. And if you look, it calculates the average value of a field for a set of points within a set of polygons. So you can use this tool to say, okay, I want to find out what the average value for magnitude is for each state, the set of polygons. Now let's say you wanted to do this for everywhere. You weren't concerned with doing it by state. Okay? Well, you could chain two tools together that we've already talked about. First, you could run the turf.extent tool, and that would give you a polygon that was the entire extent. Then the result of that extent tool would be a new polygon. Then you could feed that polygon into this tool to find out the average value for all of the earthquakes. Okay. All right, but we're going to do this for for our polygons. I mean, for the states. So let's look at the example, because I got an example down here. The example says, okay, let's find the turf dot average for our set of polygons and our set of points. And the field that we're going to use is population. What's this other? The output field. The field in the polygons to put the result. Okay. So it's going to put the results in the polygon field. Okay, so let's copy this. Control C. Okay. And I'm going to add this right. I'm going to add this to the code right here. I'm going to put a comment in our code here. Calculate the average. What are we going to say? The average magnitude by state. So we're interested in finding out what it is by state. So here we've got our code snippet that we need to modify. Where are our polygons? Which ones are going to be our polygons? What's the variable that represents, that has the information about where the polygons are stored? Do you know the name of that variable? What are we doing first of all? What polygons do we want? Just give me the. Are we using counties? What are we using? States, yeah. And so we loaded them up in this state data file, and they're actually called state data. See state data right there? So we're going to put state data right here. Okay, what are our points? Our points aren't, the variable isn't called points. Our points are called, which points are we trying to summarize? I told you before, we're trying to summarize the average magnitude of what? The earthquakes. So it's quakes. Okay, so we're finding this function is going to take the average of a polygon, the average for a polygon of a different point data set. Now the name of the field is going to be called mag, and it's going to create a new field in the averaged file that's going to give us the average. So I'm going to call this mag average. It's just what I want to call it. It's a new field. So if I console.log this averaged, I should have a new field called mag_average that tells me the average by state. So let me load that. See, that comes after the breaks. So if I reload this, and by the way, is it going to even get this one that's off of California? No, not going to get that. So it's only going to get the things that are within each of these states. So here's my feature collection. I expand it. I've got 52 features. Why do you think I have 52 features? I've got 52 states. See, it looks like Washington D.C. is its own state, quote unquote. All right. What other state might it be considering that's not really a state? Maybe. Let's see if this is it. Oh, looks like it's Puerto Rico. Looks like they actually put Puerto Rico and UV and no, sorry, that's not. Those aren't the Virgin Islands. These are the Virgin Islands over here. So yeah, it's Puerto Rico. So it's going to get a few in Puerto Rico. Anyway, so I expand this, and now inside of the properties, I have a magnitude average field. So that's the average magnitude for that state. Okay. The average magnitude for that state. Let's look at my code here. I've got small, medium, large colors. So the fill colors should be fine. I don't know if radius will screw it up, but let's do something. So watch this. I'm going to take my breaks. And right here, I'm going to come up with a quantile for my mag average for my new average data set. Notice that now I have two data sets. I have a data set called state data, and I have a data set called average D. Average D. Average D contains the same thing that state data does, except that average D has this extra field that shows my magnitudes averaged. See the difference between those two? The only difference between those two data sets is that one has this extra geometry field, this extra properties field called, oh, I expanded the wrong one. Anyway, it has an extra properties field called magnitude average. So I'm going to have my breaks 2 here, and I'm going to set up and look at what the values are in 2. Because now these are the averages for my, these are the averages. Now, I didn't plan to do this. I just thought of this as I was stepping through here. But this, where my mouse is pointed right now, these 3 values represent the magnitude values for these earthquakes, okay? And they're classified using the percentile scheme. You'll notice that the first one says NAN, which says not a number. The second one says NAN, not a number. The third one says 3.76, and this is the maximum value. Okay? Why do you think they say NAN, not a number? You got an idea? It's because most of the states don't have earthquakes in them. So I kind of got it too far ahead of myself. Yeah. Yeah, it's the JavaScript equivalent of null. Exactly. And so basically those are 0 values. So what I was trying to do was symbolize the states by their average earthquake value, and using this, only the very top values have the very top values have values. Does that make sense? Only the highest values. So maybe what I could do is modify these values to, like, let's say 90. Maybe that one works. 95. And whoops. Let's see if that works. So yeah, now the cutoff, all 3 of those cutoffs work. Let's lower them down a bit. 80, 90. I'm just curious. Okay, yeah, those might be good numbers. So now, well, yeah, let's just go. Still nothing. So yeah, maybe 90, 95, and 100. So what I could do is use these 3 numbers and actually create another one down here. Where do I add the? Oh, here's where I add the state data. Okay, so I could move this state data down to here, and instead of showing the raw state data, I can show the averaged data. And then what I could do, again, I didn't have this planned, so maybe I shouldn't do this, but oh, I'm making kind of a mess of my code here. I'm going to Control X all this and put this below my symbols. because I need the symbols. Yeah. So when I add the style, let's try first just returning large. See what happens here. Okay, so yeah, this is going to work. By the way, did any of the computers do anything at 2 o'clock? They came back up. They're done. Did all of y'all do stuff? Okay, cool. All right, great. So that means that they'll be ready for tonight. Okay, so inside of this code right here, I need to add some of that same logic that says something like this. If features.properties.magnitude it'll be breaks to let's just do 2. Yeah, that's fine. Breaks 2 or 1. That'll be fine. And then close it up and say else, and say return. Oops. Else if zero. I'm gonna go like this. 2, 1. I'm gonna go like this and say 0, small. Hopefully this works. Oh. Oh, it's mag average, mag underscore average. That's what it was in the original one, the magnitude field. Okay. So this might be something where you need to go back and look at the values to understand exactly what it's doing. 1, maybe there isn't a 2, or 0. Maybe I have to go back and understand exactly what it's doing. Yeah, I've got some issues with my code because I should be getting a value in California here and Oregon. I guess I could say properties.mag average plus. So there is a magnitude average there. If it's greater than breaks to 1, return large. Else if it's greater than Yeah, oh, it should be 0, 1, 2. That's the maximum value. Anyway, there's something wrong with my logic. I'm trying to get too fancy. But what I'm trying to do is symbolize the states by their average magnitude in the state, and just to show you that it's possible. But like a cooking show, it's usually helpful to have the already done version, but that wasn't something that I planned to do, and so I got off track. But so I have to go back there and think, why isn't this working? But for some reason, California is not getting, not showing up correctly. Neither is Utah, Texas, or Oregon. But these states are getting symbolized. And that all has to do with my my function here, okay? But notice what I did change was I changed the average. I changed this from average, I'm sorry, to average from states. And if I hadn't done that, I wouldn't have gotten this extra field called magnitude average. So that particular function that we ran up here, this function right here, what's another way of saying what it did? Or just describe what it did in your own words. What did that function do? Turf.average. What does it do? Yeah, for every point within a polygon. And to generalize it, it takes the average value of any field for every point within a polygon. So it can be useful for displaying values by state or by county or by country. You don't even have to have them on the server to symbolize them. You don't even have to have that operation done on the server in order to symbolize them. You can pull that down. So if you have, hospitals and you want to show a number of hospitals by county, or if you have people, that'd be a lot of individual points. But if you have the people and there was a small area, you didn't have a lot of people, you could do this. You don't actually even have to show the dots on the map in order for this to work. The dots on the map don't matter. Okay, so I could comment out the earthquake points, and this would still work. I'd still summarize the other layer. Okay, so another word for, or another way to describe what's gone on is that we've done a spatial join between the states layer and the points layer, or the earthquakes layer. We've done a spatial join, and then we've added them all up to create a result. Okay. All right. So I said this was not spatial, okay, but it is spatial in the fact that it's a spatial join. So there's no attribute in the points layer that said what state it was in. So in that way, it is spatial. All right. Let's look here at, let's look here at turf.js. Now let's say we just wanted to do the spatial join. There is a function for that. There is a function down here called, well, these are the three ones. Inside takes a point and a polygon and determines if the point resides inside the polygon. That's pretty straightforward and pretty simple. And there's probably applications for that, but that's just saying, okay, does this point, one point, intersect this one polygon? what if you're more interested in finding out probably a more useful thing, which is I want to find out all of the points that are within every polygon. In other words, I've got a bunch of points and I want to find out which polygon they're in. That's this one, turf.tag. Takes a set of points and a set of polygons and performs a spatial join. What this does is you could take all of your earthquakes, all of your earthquake values, and you could attach an attribute to your earthquake values to tell it which state it occurred in. Because right now there's no attribute saying which state it occurred in. And then you could only show the earthquakes for that particular state. So we're gonna do that right now. I'm going to leave this this code in here just for fun. I may even try to fix it before I post it. And what I want to do is make the states that have an average value show up as an average value, and make all the other states, leave them clear like this. Okay. I'm going to leave that up for now. What I want to do is only show this the earthquakes for a particular state. Let's say that you worked at a GIS shop in California, and you were tasked by the state of California to create this map to show me all the earthquakes. I don't care about other states. I just want to see the earthquakes in California. Okay, well, you could do this. All right. So the first thing that you would have to do, let's build on our averaged one here. I'm going to go down like this and create. I'm going to tag the averaged data set with the state data set. Okay, so I'm going to go here, copy the code from here, copy the code that's necessary to run tag. So here I say, okay, I'm going to take my points, which in this case are the quakes, and I'm going to take my polygons, which in this case is this average D data set. Okay, and then I need to know what let's see what this is. This is the polygon ID. I already know that's state. In other words, I want to transfer, or sorry, that's not state, that's name. I want to transfer the name of the state, and I want to put it in a new attribute in quakes called state. I'm gonna call it state. So now in this tagged layer, I'll have the name of the state associated with the earthquake, whereas I didn't have that before. And then just to prove that this worked, I'll console.log tagged and reload the page. So now when I hit this little button right here, sorry, not this little button. Now when I hit this guy and I look at all the features, actually this will be kind of difficult to do. Yeah. Okay, there's no state associated with that particular earthquake. Why? Okay, there's 273 earthquakes. It might be hard to think about it, but I'll tell you the reason why. Look at all those earthquakes. It looks like only about a third of them occur in the United States. So the reason why the one I picked doesn't have a state field is because it's the luck of the draw. But trust me, it worked. It put those values in there. In fact, we can test to make sure it worked by running another operation in turf called filter. So filter allows us to say, okay, I want to take an attribute and only allow this attribute through. you could write this code, but it would take you a really long time. So here's the general form. And we're going to say, okay, the filtered data set is going to be created by taking the tag data and taking the state value and only giving us California. I have to spell California right. Now I want to see just the California data sets. I need to pass filtered into the data sets for display. So now when I refresh this, I'm only going to see the earthquakes in California. Okay. So I chained together a number of GIS operations, just like you would do in ArcGIS, except for now we're doing it in JavaScript. So you need to know, in fact, in ArcGIS it's not much different. For every operation that you do in ArcGIS, you need to know what inputs you need to give it, and you need to know what the outputs are. Here we've got the name of our operation, here's the inputs, and here's the name of the output data set that's created. It's map algebra. It's just that now we're doing it in JavaScript instead of doing it in ArcGIS. So in other classes, I don't know, you've probably taken various GIS courses, but in some of your GIS courses, you probably diagrammed a GIS process. Well, if we were to diagram this GIS process, what we did, let's just ignore the fact that we averaged it because that was something I threw in there, okay? What we did was we could have done this, by the way, with just the states. I'll call the state data. And we didn't need to do it on the average data. All right, so what we did was we took the, sorry, quake. So we took the quake data and we did a spatial join. Another way that we could have said that is we did an intersect, because that would have worked in ArcGIS too, but we did a spatial join with the state data, and we said, okay, give the attribute name to the quake data, but call it states in the quake data. That's all we did. Now in ArcGIS, how would it have done differently? Well, by default, it takes all of the attribute data from the data set being joined, and it puts it in to the other data set. See what I'm saying? Anybody do a spatial join in ArcGIS before, or do an intersect? By default, it carries all the values through, right? Every single value. If I do an intersect or a spatial join, the output data set gets all of the attributes of both data sets, basically, okay? But in this JavaScript tool, it's only going to carry forth the attribute you want it to carry forth. And the reason for that is that it doesn't make a big mess, a ton of data when you don't need that extra data, because in the browser, it matters how much data you have in there, okay? If you transferred 7 attributes over, it would bog the browser down more than if you just transfer 1 attribute over. So this is transferring a single attribute. So we took the quakes data, we spatially joined it with the states data, we gave it the attribute name, and we reassigned it a new name in the output data set. So in the output data set, it's called state, not name. Okay. And so here, the second time through, all we did was say, okay, we did a, what would this be called in ArcGIS? Anybody? You'll get a high five if you can say the, and that, you have to get a virtual high five on the coast, but turf.filter, it's taking a data set and it's only giving you the values that match a certain criteria. So what would the equivalent be in ArcGIS? Yeah, select by attributes, or there's a tool that's just called select. So good job. So that's exactly right. So this turf.filter takes a data set, in this case it was the output of this other data set, and said, okay, I only want to see those values where state equals California. That's another way to read that. Okay? State has to equal California, and the output results are only ones where the state equals California. I personally think it would be awesome if there was some way to do this with a non-categorical data set. So you could, if turf.js, by the way, is open source, so you could go in there and write yourself a new function or an extension to turf.filter that that would take a greater than or less than sign. So you could say, all right, I want to filter maybe magnitude by greater than, not 100, by greater than 5. It would only show me the really big earthquakes. Okay, but that doesn't exist. We've only got filter and random. What does random do? Generates a random GeoJSON. So that might be good for like experimentation, but doesn't. Takes a feature collection of any type, property value, and in terms of matching the property value pair removed. Okay, so this is the opposite of filter. So this basically is kind of like select by attribute, but instead of selecting by attribute, the default behavior, it removes. So if I said state, in fact, I can just do this really quick to show this point. So if I said remove right here, what's gonna happen? Anybody already predict what's gonna happen? I'm gonna hit refresh. So tell me what happened. Yes, anything that met the criteria was removed instead of retained. So it's the opposite of filter. Maybe has less uses, but it's still a valid option there. Okay, sample, what does that do? Returns with the given number. So again, it finds random points. Might be good for experimentation. All right, there's all sorts of things. This is a kind of a cool thing. It's called a hex grid. This is often used on the web, actually, more than you would think. Similar to the states example that I pulled up. Let's say we had the earthquakes, and we could have if we use hex grid instead of the states, what we could do is show the number of earthquakes that happened in every hex grid. Right? We could use the current knowledge that we have and show the number of earthquakes that happened in a hex grid, and that would that might be more interesting than doing it by state. Okay, it would still be a way to aggregate it, but it would aggregate it differently than by state. Hexes are often used rather than raster cells. Why? Well, they're closer to a circle in shape. All right. Well, it's 2:40. Let's go ahead and stop at that point. There's no assignment for today. Come up with an assignment by Thursday, and we'll talk about a few other things that you could do with browser-based vector graphics. And remember, I'm not coming on Thursday because I'm going to Nicole's thesis or proposal defense, but I'll see y'all next Tuesday down on the coast. All right. I am going to post this, but I'm going to experiment with it for a few minutes in my office to see if I can get the colors right on the states.